Okay, for number two, I'm reading it. It says you have a triangle ABC with sides A, B, and C. And they give this relationship over here. It says find the angle C. That is the angle opposite to side C. So I'm going to go to the whiteboard. And I'll draw a triangle. And I'm not saying it's their triangle. I'm just saying I'm drawing a triangle. And I'll put this down over here. And I'll write down angle A, angle B, angle C. This would be side A. This is side C, side B. Now, looking at the relationship they're giving to me, I'm going to assume it has something to do with the law of cosines. I'm not sure about that yet. But let's take a look. And the first thing I'll write down is what they've given me. They've given me a cubed plus b cubed plus c cubed over a plus b plus c is equal to c squared. Well, I'm looking at this thing and I want to remind you that what we're really trying to come up with is we're trying to get the angle C. So what the relationship is, and this is going to be law of cosines. So a squared plus b squared minus 2 AB cosine of the angle C. All right? So then the question is, can I come up with this? All right? Can I come up with this? And again, their question is, find the angle C. Now, granted, if I got this, I could find the angle C, by the way. So what I'm going to do is take this and try to get that from it. Try to get that. Okay, let's see if we can do that. First thing I'm going to do is just multiply both sides by the LCD. You get a cubed plus b cubed plus c cubed is equal to a c squared plus b c squared plus c cubed. Well, I'm going to subtract c cubed from both sides. I got that covered. Then what are you left off with? A cubed plus b cubed is equal to ac squared plus bc squared. All right? Now, what are you going to do about that? I'm going to try to factor it. And to do that, the sum of perfect cubes looks pretty easy. You get a plus b times a squared minus ab plus b squared is equal to c squared a plus b. Now this is a triangle, so a plus b is not 0. So I can divide both sides by that. And what do you get? You get a squared minus ab plus b squared is equal to c squared. I'm sorry, I made a mistake. That's a b squared. All right, so I got that part there. Now, someone says, what are you trying to get? I'm trying to get this, all right? So I have sort of that, but not completely that. So what I want to do is look at that and wonder how I could possibly get that. So what I want to do is write down sort of, I got sort of that, right? I got c squared, I got a squared, I got b squared, and then I get this minus ab. But I really didn't want that. Well, I wanted this over here. So I'm going to write this over here. I'm going to try to get this. So I'm going to say, I got the c squared, a squared plus b squared. I want this thing here, right, to be this thing over here, all right? Because that's a relationship they have over here. So really, what does it say? It says that, well, let's write this down over here. So c squared equals a squared plus b squared minus 2ab cosine of angle C. All right? So looking at this, again, I'm trying to figure out what that is. And I think maybe it's not obvious, but it's there. It's definitely staring at me. So I'm going to write this over here. I want the number, whatever this thing is over here. And I'm going to say that's the number 1, right? Okay, so what I'm going to say over here, I'm going to say 2 cosine of C would have to be the number 1 for that to be true, right? For these to be equal, I'd have to have 2 cosine of C equal to 1. Well, that means cosine of C is equal to 1 over 2. And do I know an angle that gives 1 over 2? I do. I'm going to go for the reference triangle for you. Whoops, that's not a reference here. The reference would look more like this. 1, 2, root 3. And this would be 60 degrees, by the way. So C is 60 degrees. Or if you prefer, you want to go to radian, pi over 3. And we're done. Thank you.